Students, now we'll see about sign conventions. Okay, so we have sign conventions to be learned now. So, sign conventions for IR drops and battery EMFs. So, how we have to make out the sign for some resistor which is connected and for the EMF sources what we will connect in a circuit. So, how we have to take which terminal as positive, which terminal as negative. Okay, that will be seen when it comes to some EMF source connected and some current is flowing in a loop, and we will be talking about loop current. So what is loop current? So we have a closed path in a circuit. So now this I will be calling it as what? One loop, isn't it? Loop I will be calling it as, and the current which flows in this loop. The current which flows in this loop is called as what? Loop current. Fine. So the current which flows is called as what? Loop current. So in a loop, in a closed path, some current will be flowing because of some voltage source which has been given. So that current which is flowing in that loop is called as what? That particular loop's current, or loop current will call it as. Okay, fine. Yes. So now we will see the sign convention. So how we have to consider which terminal is positive, which terminal is negative. Okay. So for voltage source we know that. Okay. So the larger terminal for DC voltage source. So the larger terminal, like the larger line is a positive terminal, and this is a negative terminal. You know that. Okay. So because of like when I have this EMF source, so then the current always flows from positive of the battery towards what? Negative of the battery. We know that. Okay. So the current flows in this direction. So we know that. So this is denoted by a 1. So current I flows like this. Correct or not? Okay, fine. So now we have some EMF which has been connected in that particular loop, and that loop has got some other current which is flowing in this direction. Okay, so we have this EMF source, so that is there. Okay, so if this EMF source has been connected to a loop wherein some loop current is flowing. So this is the direction of loop current. So this arrow mark indicates the direction of loop current. Okay, so some like this is your EMF source what I have connected in a loop. Okay, so in that loop some loop current is flowing in this direction. So then now EMF source current flowing direction is same as that of the direction of loop current. Okay, so this EMF source will make current in this direction, and the direction of loop current is also in the same direction. So then I can consider this EMF source as what? Positive. Fine. So then considering with this loop current, so I can consider this EMF source as what? Positive. Fine. So this is a positive EMF source for this loop current which is flowing in that particular loop. Is that okay? Because by I'm calling this EMF source as positive because this EMF source is making some current to flow. The current, it is making some current to flow in the loop which is in the direction of the loop current itself. Okay, so the direction of this EMF source which is making some current. Okay, so the direction of current this EMF source is making, so that is same as that of the direction of loop current. So then I can consider this EMF source as positive. Okay, I will be seeing for another circuit or another EMF source. So wherein I have this EMF source positive terminal this side and negative terminal this side. Okay, so then this is your positive, this is your negative, and now this EMF source will make some current in this direction. Obviously, current flows from positive of the battery towards negative of the battery. So this is making some current I which will be in this direction, but the direction of your loop current is in the same direction as that of before. Okay, so now the EMF source is reversed. Okay, so now what happens here is, so this EMF source will make some current which will be flowing in this direction, and the direction of loop current is in this direction. So then for this loop current what I am considering, okay, for this loop current what I am considering, so the direction of loop current is opposite to that of this EMF source current, isn't it? So then I have to consider this EMF source as what? Negative EMF source for this loop current what I am considering. Fine, is that okay? So for this loop current, or for this, like when I consider this within the loop, if I go for the direction of loop current, so this loop current is taken as what? The major current. Fine. So it is treated as what? Major current. We will see other currents with respect to this. So this is our major current, and we will be seeing which direction this is flowing, and if this EMF source is making some current in the opposite direction to that of the loop current, so then I will consider this EMF as what? Negative EMF source. Is that okay? Fine. So this is how I can give the sign convention for your EMF source as positive and negative. Is that okay? Fine. Yes. So now we will be saying for some IR drop. IR drop in the sense what? The current drop, or the voltage drop which is happening across resistor. Okay. So we have some resistor and we will be calling IR drop. IR drop means what? The voltage drop. You know that V is equal to I into R. Okay, by Ohm's law we know that V is equal to I into R. So instead of telling voltage drop, we are calling it as what? IR drop. Okay, so IR drop they are calling it as. Okay, so IR drop means what? The voltage drop across your resistor. Okay, so because instead of calling it as a voltage drop, they are calling it as what? IR drop. Okay, so both means same. Voltage drop or IR drop, both means same. So current into resistance, that is equal to your voltage. Okay, so we have this IR drop which is happening. So now how to consider which terminal will be positive? How to consider which terminal will be positive? We'll be seeing that. Okay, so now usually if some current, if I have some resistor like this, so some current if enters into the resistor from this end, so then usually we will be making this terminal as positive, this terminal as negative. Okay, the terminal to which the current enters into the resistor, so then the voltage which will be dropped across this resistor will be given the polarity as what? This terminal is positive, this terminal is negative. Why? Because the current has entered in this direction into this resistor. Fine. So that is the basic idea. Okay, so basic idea is what? Now we have some current which will be entering into this resistor in this direction. That means what? So the voltage which will be dropped across this resistor will have the polarity so and so. Positive this direction, negative this direction. Why? Because the current has entered in this direction. Okay, so the current has entered in this direction. So then this will be positive, this will be negative for this voltage drop which is happening across this resistor. Okay, so now for if direction of current, if the current was, or else I am showing here only. Okay, here only I will be showing if I have the current into this resistor is flowing in this direction. Okay, so the current is coming from this direction into this resistor. So then this IR drop can be given a voltage or a sign convention of what? Positive here, negative here. Is that okay? So the voltage drop across this resistor will have this polarity, positive this direction, negative this direction. So that will be the polarity of your voltage drop or IR drop across this resistor. If the current is flowing in the, like current is entering into the resistor from this direction. Is that okay? Yes. So now we will come to this example which has been given here. Direction of current. Direction of current into this resistor is in this direction now. Okay. So now we will come to see how to give the how to treat this voltage drop or this voltage drop across your resistor as compared to the direction of the loop current. Okay. Yes. So now in this direction of your current, the current which will be flowing into this resistor is in this direction. Okay. So now there will be a voltage drop here. So that we call it as what? IR drop. So now this is the thing which is there, and this circuit has been connected to this is the thing which will be connected to there is like we have some loop current in that particular loop. Okay, this has been connected in the loop, and the loop current or the direction of loop current is in this direction. Okay, so now direction which will be direction of current which is going into this resistor is in this direction, and we have this direction of loop current in that particular loop is again in this direction. Okay, means the loop direction of loop current and the direction of current which is flowing into this resistor, both are when both of the things are in the same direction, so then I can consider this IR drop or this voltage drop as positive voltage drop. with respect to what? The direction of loop current. Is that okay? Same as that of this EMF source. Okay. So now I will be considering this IR drop, which is happening across this resistor as what? Positive with respect to this loop current, because this loop current is in this direction and the current which flows into this resistor is also in the same direction. So then I can consider this IR drop as what? Positive to this loop current. I can consider it as okay. So now we come for the other direction. Okay. So here we have this direction of current. Here we have this direction of current which will be flowing into this resistor is in this direction. The current is flowing in this direction. So then IR drop is treated as what? Now the current flow is in this direction and this direction of loop current is in the same direction as that of before. Okay, so the loop current is flowing in this direction and the current which is flowing into the resistor is in this direction, opposite direction. So then I have to consider this voltage drop as what? Negative. This voltage drop as negative with respect to this loop current. So when I consider, because our loop current is the major one, okay, so I will be considering whether this voltage drop or this current which will be flowing into this resistance or resistor is in the same direction or opposite direction. If it is in the same direction, I can consider this voltage drop as what? IR drop as what? Positive. And now here the thing comes is that it is this voltage drop has to be treated as what? Negative, because it is making some current in the opposite direction. Is that okay? Fine? Is that clear? Okay. So this is how we will be giving the sign conventions to your EMF sources and the IR drops. Fine? Is that okay? Yes. So now we will see like yeah. Okay. So here the current which is flowing inside this resistor will be making some voltage drop in this direction. Fine. So when I consider in this direction the loop, when I consider with respect to the loop current, so the loop current is in this direction. So then for this loop current, here comes the negative terminal first. So this is negative. For this loop current, now that the direction of current which is flowing into this resistor is what? In this direction. So then this will be positive, this will be negative. Okay. So when I say for this loop current, so loop current is flowing in this direction. It means what? So this can be used. Okay. Or this IR drop is what? Positive with respect to this direction of the loop current. Okay. So in that way also we can remember this. Okay. So this will be positive because it is making some current in the same direction as that of the loop current, and this is making some current in the opposite direction of this loop current. That is why it is this IR drop is taken as what? Negative to this loop current. Fine. Yes. Now we will be seeing some example of. For example, I will be seeing. Okay. So where in this example we have two voltage sources E1 and E2 which are connected. Okay. Now here we have two resistances R1 and R2. Okay. So we have two voltage sources E1 and E2 and two resistors connected R1 and R2, and there will be a voltage. And then let us consider that E1 is greater. Let us consider that E1 is greater than E2. Now we consider that E1 is greater than E2. So effect of E1 will be major than E2. Is that okay? Yes. So now, or else if I say, so the direction of loop current is in this direction. So that means what? E1 is greater than E2. Why? Because it is making some, like the direction of loop current is in this direction. If I say in that way, so that means what? E1 is making major current than E2. So when E1 is making major current than E2 means what? E1 is greater than E2. EMF source E1 is greater than EMF source E2. Is that okay? Fine? Yes. So for voltage sources, sometimes we will call them as what? EMF source or E will represent them as, otherwise we will represent them as what? V. V1, V2. Okay, and likewise also we can name them. Is that okay? Fine? Yes. Now they have given it as what? E1 and E2, and the voltage drop across is if some conventional current I or if some current I which is flowing into this loop. Okay, if some current I is flowing into this loop, or the direction of loop current will be in this direction. Okay, fine. Then the voltage drop across this resistor will be what? IR1, and voltage drop across this resistor will be what? IR2. isn't it? Same current flows. Okay, so fine. So IR1, IR2 are the voltage drops across the resistance R1 and R2. Fine. So now when considering this loop current I, which is all because of your E1 and E2 also makes some current. So how it is making, in which direction we will see. Okay, now. Okay, so now E1 is making some loop current which will be from positive of the battery towards the negative of the battery. Fine. Is that okay? Now coming to E2. E2 is making some current. So here it is. Here is its positive direction, like positive terminal. Here is its negative terminal. So then this E2 will make some current which will be in the opposite direction to that of your E1. Fine. Is that okay? So now E2 is making current in this direction. E1 is making current in this direction. E2 is making current in the opposite direction to that of E1. So now what we are considering is, so the direction of conventional current or the direction of loop current is in this direction. That means what? E1's current or E1 is the major voltage source here. So E1 is greater than E2. So the current which will be flowing into the loop is all because of this E1. So now the direction of loop current we are considering in this direction. That means what? So now I have to consider these IR drops. Okay, so now the voltage drop across this R1 is given the polarity positive and negative because the major current will be entering into this resistor in this fashion, right? Plus minus. So likewise it will be entering. So here it is positive, here it is negative. Okay. So when it comes to this resistor, again this conventional current it will be flowing in this direction, right? Likewise it will be flowing, and also it enters into the resistor R2 where we have this voltage drop IR2 and this terminal will become positive, this terminal will be negative because the current enters like this. Fine. Okay. So all because of this resistor, like EMF source E1. Now here we have this EMF source E2 which will make some current in the opposite direction. When I consider this loop current I which is flowing into this loop, so now for this loop current what all things will come into picture as what? So if I have to consider, so now this EMF source E1 will be considered as what? Positive. Okay, because it is making all the current, isn't it or not? Okay, so now E1 is positive because it is making some current in the direction of the, means it is the thing which will be making the loop current or the current will be the major current will be flowing into the loop. Okay, so now this E1 will be positive, obviously it will be positive, and then coming to this direction, then this current, conventional current flows in this direction and it enters here in this opposite direction to that of E1. E1 is making some current which is in the opposite direction to that of this loop current. So then E1 has to be taken as what? Negative. Why? Because here we can see the direction of loop current is in this direction and the EMF source is making current in this direction. So then I have to take this EMF source as well negative. So then E2 is negative, we will write it as. Okay, so E1 is positive, E2 is negative, we will write it as, because it is making some current which is opposite to the direction of the loop current. Fine? Yes. So then coming to IR drops. So here I am seeing, so the current is entering in this direction. Okay, so the current is entering in this direction and the voltage drop which has happened across this resistor is also in the same direction. So then I can take this as what? Positive, and also here the current which will be flowing in this resistor will be same as that of the loop current. So that is also because of this some current has entered into this resistor in this direction. That's why the voltage drop is happening as what? Positive, negative. So then I will be considering this IR drop as what? Again positive. Is that okay? Fine. So when considering the loop current in this direction, okay. So if I consider some loop current in the direction like this, fine. So then I have to consider this as positive, this as positive, this as negative, this as positive. Fine. So likewise we will be going for them according to KVL. If I apply Kirchhoff'S voltage law here, so I can write that thing as what? E1. So voltage sources will be considering at one side and the IR drops at the other side we will equate it. Okay, so the total about what does the voltage like Kirchhoff's voltage law says us, what it says, the sum of EMFs is equal to sum of voltage drops in a loop. Okay, sum of algebraic sum of the EMFs is equal to algebraic sum of the IR drops in that particular loop. Fine? Yes. So that is what we have written here. So E1 minus, because E2 is minus, so E1 minus E2 is equal to IR1. Both are positive, right? IR drops, both the IR drops are positive. So IR1 plus IR2 we can write it as. Okay. So E1 minus E2 is equal to IR1 plus IR2 we can write it as. Fine? Is that okay? This voltage source, 5 volts of voltage source. So it is making some current in this direction. And here comes the 2 volts of voltage source, which will be making some current in the opposite direction. So then this will be treated as what? Minus to that of this voltage source. And always we have to consider the larger voltage source, because that will be the head in that particular circuit. Okay, so here it is head. So here it is like a little bit lesser voltage source, because its effect will be more than that of this. So then what I have to do is, so 5 volts of voltage source, so it is making some current, so its current will be lesser than that of this. So then what we have to consider, this total voltage which will be affected to your resistance R can be found out as what? So it is what we have to do is what? 5 volts minus 2 volts we have to do. The total voltage which will be affected to this. Why it is minus, why it is minus 2 volts we have to take it as, because when I consider this, so this is greater, so we will consider the loop current which will be flowing into this loop will be in this direction. Obviously in this direction it will be, because this is higher voltage source, so this will make some current, or loop current which will be flowing into the circuit will be in this direction. So this is positive. Okay, now this is positive, and voltage drop across your resistance will be in this direction. Fine? Is that okay? So in this direction, IR drop will be in this direction, and when it comes to this direction, so this voltage source is in the opposite direction. It is making some current in the opposite direction. So then I have to take this as what? Minus. I have to take this as what? Negative. Fine? So then the total voltage which will be affected to this resistance R will be what? 5 volts minus 2 volts, that is equal to what? 3 volts of voltage, which will make some current which will be flowing into this resistance, and that we are going to find now. Okay, so now I can be written as by Ohm's law. I can write I is equal to V by R. So the total voltage which will be affecting is what? 5 minus 2 volts, that is equal to 3 volts, divided by the resistance is equal to 300 ohms. So 3 minus 300, that will be what? 0.01 amperes. So I can write this as what? 10 milliamperes. 10 milli in the sense what? 10 to minus 3. Okay? So I can write this as what? 0.01. Instead of writing like this, I can write it as what? I can shift this 0 3 times towards that side. That will make what? 10 into 10 power minus 3 amperes. So 10 power minus 3 can be written as what? Milliamperes. 10 milliamperes of current I can write. You can write in this fashion also, or instead of writing in this instead of writing in this manner, you can write it in a standard manner of 10 milliamperes. Okay, is that okay? Fine. So if you write 0.01 amperes, no problem. Okay, so you can write, or you can represent it in a some good manner in the form of 10 milliamperes. Fine. Yes. So now coming to another example, here calculate the current I flowing into node N. Okay, so here we have what? Considered a node N. Node N we have considered. Here 3 amperes of current is flowing in this direction, and some I current I, which is unknown, is flowing in this direction, and means 3 amperes of current and this unknown current both are entering the node, and 2 amperes of current is leaving the node. Is that okay? 3 amperes and I currents are entering the node N, and 2 amperes of current is leaving the node N. And then from Kirchhoff'S current law, I can write this equation as what? 3 amperes plus I is equal to 2 amperes. Fine. Is that okay? Current entering the node is equal to current leaving the node. Okay. Yes. So then I can rearrange the things. I is equal to so then I can calculate what is I. I can take this side like this side. So then I can write as what I is equal to 2 amperes minus 3 amperes, that is equal to minus 1 amperes of current will be. Is that okay? Fine. We have a voltage source, we have a resistance R1 and R2 and R3, and we have two loops, loop 1, loop 2, and here some current flows because of this voltage source I1 current flows, and this current I1 comes here and it divides here. So here we have got two nodes over here, and at this node the current divides into two parts. So I will mark the current which will be flowing through R2 as what? I2. Fine. So this will be marking it as what? I2, and the rest of the current I1 currents, some part will be coming as what? I2. So then remaining will be what? I1 minus I2. Is that okay? I1 is coming at this point and it will be divided into two parts. So I take one part as what? I2. So what is the remaining thing? So it will be I1 minus I2 will be coming through this, or will be flowing through this resistance R3. Is that it or not? So the current I1 minus I2 will be flowing through this resistance R3. So then we have to analyze this circuit now. Okay. So we will apply Kirchhoff's voltage law to this loop and this loop 1 and loop 2 separately. So then we will see how the things will come into picture. Okay. So now applying Kirchhoff's voltage law to loop 1. To this loop 1 we will be applying Kirchhoff's voltage law, and we will see properly what happens. Okay. So I can write this as what? V. Kirchhoff's voltage law says what? Sum of EMFs is equal to sum of the voltage drop. Algebraic sum of the EMFs applied will be equal to what? The algebraic sum of the voltage drops. Here and here we have for this loop. Okay, so we have two resistances which are there in this loop 1. Okay, so the loop 1 will be in this direction. Okay, applying KVL to loop 1, what we'll get is what? V is equal to the current which will be flowing is what? I1. Voltage drop will be what now? Here the voltage drop will be what? I1 into R1. Is that it or not? So that is what we have written here. I1 into R1, and this current comes here and it flows through here. This current comes here and it will divide here, isn't it? And the current which flows through R2 is what? I2 now. Fine or not? Okay, the current which flows through R2 is I2 instead I1. I1 flows through R1, and when it comes here, it will divide into two parts. So now here the current which flows through R2 is what? I2. So now the voltage drop here will be written as what? I2 into R2. The voltage drop or the IR drop which will be happening across this resistance R2 is what? I2 R2. I2 R2 I have written. So applying KVL to this loop 1, I can write it as what? V is equal to I1 R1 plus I2 R2. Okay, fine? Yes. Now applying KVL to loop 2. To this loop, if I apply Kirchhoff's voltage law, whether can we see any of the voltage or EMF source here? No, we don't have any EMF source here. We have the EMF source only to loop 1. To loop 2, we don't have any EMF source. So then I can write the EMF source as what? 0. Is that okay? So I will be writing it as what? 0, because there is no EMF source to this loop 2. So I will be writing it as what? 0. Fine. So now 0, and the current which flows through, that 0 is equal to yes 0 is equal to, okay, so we have what? Resistance R3 will have what current? The current which flows through R3 is said as what? I1 minus I2. Yes or no? It is I1 minus I2. So I have named it as what? I1 minus I2. So then I will be writing the voltage drop here as what? I1 minus I2 into R3. So the voltage drop across this resistance R3 as what? I1 minus I2 is the current into the resistance. So this is the voltage drop across the resistor R3. So I1 minus I2 into R3 is the voltage drop across this resistance R3, and after this the loop comes like this, and also it will go in this manner. Isn't it or not? Okay. So the loop current comes like this, like this it will be going, and it will be going like this back, isn't it? So while going back, it will come across, means it will come into it will go through the resistance R2. So then R2 current, the current which will be flowing through R2 also has to be considered. Okay, isn't it or not? Okay, so this loop current will be flowing in this direction back to the point where it has started. Yes or no? So then how this resistance R2 which will be coming into picture. Okay, so then for this loop current, so now what we have considered as sign conventions, what we have considered, we have to memorize those things, isn't it? So we have to remember those things very properly. So when this current, now loop current is the major current what I am talking about, okay, not the other current. Okay, so now this loop current is flowing in this direction, that will make the voltage drop across R3 as what? I1 minus I2 into R3, and this current will be flowing in this manner. So then resistance R2 is coming into picture. So then I have to consider the voltage drop here also. Okay, so but this voltage drop, now this current is making it like this loop current will be flowing in this direction, opposite direction to that of the current which is flowing in this direction. Okay, so the current through R2 is in the opposite direction to that of this loop current 2. Isn't it or not? So in this loop 2, some current will be flowing, but this current which is flowing through your loop 2 is in the opposite direction to that of the current which will be flowing through your R2. So then I should consider this voltage drop as what? Negative. So that we have to remember properly. So then I can write this voltage drop, okay, with respect to this loop current as what? Negative. So then I will be writing it as what? Minus I2 minus, it is I2, yes, I2 which will be flowing through your R2. So it is what? Minus I2 into R2. So this is your R2, resistance R2, isn't it? So this loop current will be flowing in this direction. So then here comes some resistance R2 into picture, and the current which will be flowing in this flowing through your R2 will be in the opposite direction to that loop current. So then with respect to this loop current, I should consider this as what? Minus R2 minus I2 into R2. I have to consider that as, okay. So another sign conventions thing. Okay, so it is very important. Sign conventions are very important when it comes to circuit analysis using Kirchhoff's law and whatever it may be. Okay, so sign conventions are very important. The direction of loop current and the EMF sources or the IR drops things. Okay, so here we have this loop current in this direction, and there is some current which is already flown into your resistance R2 that will be in the opposite direction. So then with respect to this is negative. Okay, so this voltage drop will be negative. So that is why I have to consider this as what? Minus I2 R2. When I rearrange the things, so I will like I have I1 and I1, so I can multiply this with this. Okay, R3 I1 into R3 minus I2 into R3 minus I2 R2, I can write it as well, and then I can take the term I2 as common. So I can take I2, means we have what? I2 twice, so then I can take I2 as common here, and I can write it as what? Finally I can write this equation as what? 0 is equal to I1 R3 minus I2 has taken common into what? R2 plus R3, we can write it as, okay. So after solving the things, okay, so I can write this equation as what? R2. Okay, now we have equation 1 and equation 2 for this loop 1 and loop 2. Now after solving all these things, okay, so when this is simple circuit, like a simple example what has been given for circuit analysis, and we haven't given any of the values here. Okay, then they give some values, you can solve the equations like this, and you can put the values and solve these two equations simultaneously. You will get the values of your I1, I2 and I1 minus I2. Okay, so for this circuit analysis we have taken some example over here. So we have some example to find the branch currents. Our example is to find the branch current. This is very important question. Okay, so they have asked this question many times in many of the exams. Okay, so in many exams they have asked this question. Same question they have asked. Okay, fine. Yes. So now we have a circuit wherein we have a voltage source of 15 volts and resistances of 10 ohms, 5 ohms and 20 ohms as R1, R2 and R3, and we have some current as what I1, and we have some another current which will be flowing through your R2 as what I2, and we have the remaining current I1 minus I2 will be flowing through your resistance R3. Is that okay? Yes. Now apply, now we'll solve this circuit. Okay, so applying Kirchhoff's voltage law to loop 1, to this loop 1, if I apply Kirchhoff's voltage law, then it will be like what is the voltage source? It is 15 volts, that is equal to what? 10 ohms of resistance. 10 into I1, it is 10 I1 plus what is this voltage drop as? It is 5 ohms of resistance we have. I2 into R2. What is R2? It is 5 ohms. I have directly put the values, not the resistance R2. Okay, the value of that resistance I have put directly. So then I can write it as what? 5 I2. Okay, so this equation 1 I can, in this loop, the equation 1 I can have as what? 15 volts is equal to 10 I1 plus 5 I2. I can write this equation as equation 1. Okay, now applying Kirchhoff's voltage law to loop 2. To this loop, if I apply Kirchhoff's voltage law, same as of this example. It is same example I have taken over there, but I have given all the values. Okay, so then I can solve the equation and we can get the values of your current I1, I2 and I3. So that is our equation is to find the branch currents. All the branch currents I have to find. So to this branch and to this branch and to this branch I have to find what all currents have, which all the currents, how much, what all currents will be flowing in the branches. Okay. Now applying Kirchhoff's voltage law to loop 2, I can write here there is no unit source. Directly I can write it as what? 0 volts. 0 is equal to 20. So 20 ohms of resistance, isn't it? So it is 20 into I1 minus I2. Okay. So then minus. So the current through the loop current is in this direction, and the current through your R2 is in the opposite direction. So then I have to consider this voltage drop as what? Minus 5 into I2. Minus 5 into I2 I can write it as. So finally I can rearrange the things likewise as done before. So I can rearrange the things and I can write the final equation as what? 0 is equal to 20 I1 minus 25 I2. So it will be like, it is, I will multiply this, isn't it? 20 I1 minus 20 I2 minus 5 I2 minus 20 I2 minus 5 I2 will be what? Minus 25 I2. So then I can write this equation as equation 2. Now solving these two equations simultaneously, if I simplify this equation, simplifying equation 1 and 2, I will be getting the thing that's what? 75 will be equal to what? 70 I1 and be getting steps. Okay. So then after solving this equation, these two equations simultaneously, I will be getting it as what? 70 will be 25 is equal to 70 into I1, and then I can find I1 as what? I1 is equal to what? 75 divided by 70. If I do, it will be what? 1.07 amperes. 1.07 amperes of current I will be getting. Okay. So I hope that you are aware of how to solve these two equations, isn't it? Yes. So it is very easy, isn't it? Correct or not? Simultaneously we can solve these two equations like this, isn't it? So it is 15 is equal to 10 I1 plus 5 I2 I can write, and it is, that is equation 1. This is equation 2. It is 20 I1 minus 25 I2. So now we have to see for some term which is going to come as what? Common, isn't it? So now here if I have to go for what I can say is, so if here we have some term as what? Positive. Here we have I2 as what? Positive. This voltage drop as what? Positive. Here we have I2 as what? Minus. So then I can directly now if I can make this 5 as what? 25, and then I can cancel this term, isn't it? So that is what we will be doing. So to make to cancel this I2 this term, to cancel this term, so what I will do is I will multiply this equation 1 with what? 5 if I multiply. So then the thing will be something different. So it will be, if I multiply these two things, so then if I multiply this equation 1 with 5. Okay, so then it will be what? 75. Then this will be what? 5 into 10 will be 50. And how much it will be? It is 25. 5 5 is 25. Right? So now if I have to, like, if I go for solution, so this term will get cancelled out, isn't it? Plus 25i2 minus 25i2, both will get cancelled out, and the remaining string will be, now what I have to do is what I have to add it, isn't it? Yes. So now what it will be? 25 plus 0 is 75, that is 50 plus 20 will be 70i1. So that thing, what 75 is equal to 70i1, we can write it as, and finally I can calculate what i1 I can calculate. Now after getting i1, I can put this value of i1 in equation 2 and I can get the value of i2, or also I can put this value of i1 in this equation also, then I can get the value of i2 also. Okay, so that is also possible here also. Otherwise I can put this out here. Okay, so directly I am getting the thing done. So what is that? That is 0 will be equal to what? 20 i1 minus 25 i2 if I write. So here I will give the value of what is that? Yes. So now like 0. This is how I can write, and we have got the value of i1, we want the value of i2, isn't it? So i2 value I have to find, so then I can write this as what it is. If I take this thing this direction, so I can write as what 25i2 can represent what 20 i1 I can write it as. So now I will be putting the value of i1, it is 20 into 1.07 amperes if I do, and divided by 25 I have to do, isn't it? So now it is 25 i2. So if i2 will be equal to what? 20 into 1.07 divided by 25 if I do, you will be getting it as what? It to be 0.4 amperes. Okay, so you can solve it and you can see it will be coming to the same value. Fine? Yes. Once I get this value of i2, so then I can calculate the value of i1 as what? Once I get the value of i1 and i2, I can go for the solution of to find the value of, I have got the branch current i1, I have got branch current i2. Now I can calculate branch current i3, means not i3, the current which will going through resistance R3 as what? i1 minus i2. So what is i1? What is i1? i1 is what? Is equal to 1.07 amperes. i2 is what? 0.4 amperes. And I can find i1 minus i2 as what? It is 0.67 amperes I will be getting that. Is that okay? Fine? Yes. So this is how we will be solving the example for finding out the branch currents.